We learned about carbon compounds, saturated, unsaturated, alkane, alkene, alkyne, yes, all these, okay? So now we need to learn about functional group. You know, a functional group can be an atom, okay? It can be a single atom or a group of atom. It can be an atom or group of atom, okay? Which when attack a hydrocarbon, they decide all the properties. They decide all the chemical properties. This is what we call it as a functional group. Okay. So now the major functional groups we need to be thorough with. First type of group, we call it as the halo groups. Okay. That means any halogen can come. Halo groups. Any halogen group can come. For example, we have chlorine, fluorine, iodine, etc. Okay. The second group, which is normally coming, is the alcohol group. Actually, from now onwards, all are oxygen family. Alcohol means it should have OH group. Okay. There is an OH group. We call it as alcohol. And OH group means the end name will end in OL. The third one is alcohol. Then we have aldehyde group. Aldehyde means C, single bond H, double bond O. Basically, we say it as CHO group. Okay. So this will be connected to any alkane group. And the name will end in AL. And the next group, we call it as ketone group. Ketone group means it is C double bond O. So both the carbons are free for bonding. And ketone will end in ONE. And the last group is the acid group. Acid group is C, okay, OO and OH. This is the acid group. C double bond O, OH. That means it's a mix of your alcohol and ketone together. And this name will end in OIC, acid. Okay. So for the minimum number of ketone, for a ketone, it should have minimum 3. So propanone is the simplest ketone group. Why we need 3? Because functional group itself has a C, and to the both the side a C should come. So these are the major functional groups. Okay. So suppose if we are taking alcohol. Alcohol, how is it made is, you take the corresponding alkane, okay, remove H, okay, remove one hydrogen and add OH group. This is how we make an alcohol. Let's see an alkane CH4. What you will get when you remove a H? It will become CH3. To that, who is added? An OH group is added. So what will be the name of this? It has only one carbon, so it will be meth. It was methane. And that E should be replaced by OL. So this is called methanol. If you are taking the next one, for example, C2H6, what will happen? This will become C2H5OH. Okay, C2H5OH, C2 means ethane. So ethane, E will be replaced by OL. So this is called as ethanol. I hope this is clear. And instead of OH, if we are adding COOH, you will get the corresponding acid. The problem with this is the carbon is already present in the functional group. So, what is the simplest alcohol acid possible? COOH can be connected to H. So, this is called as methanoic acid. Okay. And what should be the next member? Suppose COOH. What is the next member? Carbon? Carbon. So, what is the valency there? 3. So, what is the formula? CH3, COOH. That means 2 carbons are there. So it is ethane. And it should end in OIC acid, ethanoic acid. So these are the major functional groups. Okay. So when we are naming, how do we name it is, first you need to take the longest chain. Okay. For example, CH3, CH2, 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 CH, CH3, and here I have a substituent. Okay, so I have to find the longest chain. So how will I name it? 1, 2, 3, 4, 5, 6. One way of naming. Second way of naming is the reverse one. 1, 2, 3, 4, 5, 6. Okay, so take the number so that the substituent get the least number. So which is least, 5 or 2? 2 is the least. So how do we name this is, what is the actual? It has 6 means it should have hex. There is no double bond or triple bond, so it should be a single bond, hexane. Now, who has come? A chloro group has come. Which carbon the chloro group has come? In the second carbon. So it is called as 2-chlorohexane. So instead of chlorine, if it was CH3 group, what we will call that as 2-methyl-hexane. Okay. So priority goes to the substituents. Okay. And first priority is for bond. Second priority is for functional group. Okay. And the third one is for the alkyl group which is attached. So this is how normally we name the compound. Okay. And one of the repeated questions from this is, what are isomers? Okay. Isomers are compounds which has same chemical formula. Okay. It has same chemical formula, but different structure. So let's see the first one. Okay, suppose if I have a compound C4H10. Okay, so how do I write the first structure? 1, 2, 3, 4. Okay, then how many hydrogens are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the first structure possible. What is the second structure possible is, instead of 4, I will make it only 3 and 1 will come to the side chain. And you check the number again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means these are the 2 possible isomers for C4H10. Okay, so this is how we find the isomers. Let's go for C5H12. What are the possible isomers? The first one is 1, 2, 3, 4, 5. All in one chain. Second is 1, 2, 3, 4, one side chain. Okay. Third one, 1, 2, 3, 2 inside chain. These are the possible isomers. Let's see the number of hydrogen. Everywhere it should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, all of them have the same atomic formula but different structure. These are called as isomers. Now we need to know about the major reactions. Major reactions by hydrocarbons include, the first one is combustion reaction. Okay, the first one is called combustion reaction. Combustion reaction means it is burning in presence of air. Combustion simply means it is the burning in presence of air. So what is the byproduct or the product after combustion is always the same product. For example, CH4, if it burns, it will give what all things? Carbon dioxide, water, heat, and light. These are the products of combustion. Second reaction, and in this case, if it is incomplete combustion, okay, if the combustion is incomplete, it give you a sooty flame because of the incomplete combustion. Now, the second reaction is called as oxidation reaction. Oxidation reaction. Oxidation means either it can be addition of hydrogen, so oxygen, addition of oxygen, or removal of hydrogen. Okay, so let's see CH3 CH2OH. This is ethanol. When we oxidize this, oxidation takes place in presence of an oxidizing agent. And the oxidizing agents are either alkaline, KMNO4, or acidified, K2CR2O7. And the products are CH3. What exactly happened is a CH2 group is removed. Okay, and who enters that? Oxygen. Oxygen has valency 2, so it can replace 2 hydrogen. So what do we get is CH3COOH. So what will happen when a hydrocarbon is oxidized? Hydrocarbon means your alcohol will be converted to acid when oxidized. And who helps in this is the oxidizing agent, alkaline KMNO4 or acidified K2CR2O7. Third reaction, we call it as addition reaction. Addition reaction means something is being added. So in addition reaction, it can happen only with unsaturated hydrocarbons. When addition takes place, that means hydrogen is added, the catalyst required is nickel. What are catalysts? They are materials which speed up the reaction, but they will not take part in the reaction. So here the bond will break, okay? So each carbon will get a free. So what do we get is, first one, already it had H2, now one more H will come. So it is CH3, single bond CH3. Okay, this is what we call it as addition reaction. And basically, unsaturated compounds will turn saturated. Okay, so this vegetable oil, when it is added with hydrogen, we call it as hydrogenation, then you get the corresponding animal fat, okay, like vanaspati and all, which is actually bad for health. But why we do that is for preserving it, we do the hydrogenation. Coming to the fourth one, the addition reaction. After addition reaction comes substitution reaction. So what happens in a substitution reaction is, each time when chlorine is added, it will substitute the hydrogen. That means one hydrogen will be removed and in place a chlorine will come. So one chlorine is free here, one hydrogen was removed, so it gives you HCl. Now again, when you chlorinate, like CH3Cl, when again chlorine is added, what will happen? One more chlorine will get entered by removing one more hydrogen. So it will become CH2Cl2 and again HCl. Again, when you hydrogenate, what will happen? CH2Cl2 plus again chlorination means it will become one more hydrogen is removed and chlorine will become 3, CHCl3 plus HCl. And the last is, if CHCl3 is again chlorinated, what will happen? Your full H will go. So you will get it as CCl4 plus HCl. Now no more hydrogen is there to remove and hence the reaction will stop. Now in the chapter, we need to learn about some important carbon compounds and the cleansing action of soap and detergents.